March 28, 1918, we took off to support our infantry at an altitude of no more than 260 feet. The aircraft received over 100 hits. My helmet was pierced, but the observer managed to bandage the wound. I am convinced that only the Junkers aircraft saved my life. No other machine today could have done more. This eloquent recommendation was given to the Junkers J.I, the first serial all-metal aircraft, by Lieutenant Wagner, a veteran of the First World War who served in Fliegerabteilung 268. The emergence of infantry aircraft was partly due to the British, who during the Battle of the Somme began using so-called contact patrols. These were two-seat fighters, or reconnaissance bombers, that not only observed German troop movements but also destroyed enemy personnel and equipment. However, during such operations, losses from ground fire increased sharply when attacking from low altitudes. The best way to solve this problem was to armor the aircraft, although similar work had been conducted earlier. The Germans were the first to take it seriously. On November 4, 1916, the German Air Service headquarters issued a task to develop special armored aircraft for direct support. These machines were called infantry airplanes, or given the J specification. This specification required the creation of an aircraft in which the crew, engine, and fuel were entirely enclosed by 5mm chrome nickel steel armor, providing protection against small arms fire. The service ceiling was limited to 4,900 feet. Initially, the armament was limited to a single machine gun on a turret for rear defense. The standard equipment was to include a camera and a radio station. One of the companies that began developing such an aircraft was Junkers Flugzeugwerke AG. The aircraft in question was the creation of the brilliant scientist Professor Hugo Junkers. Throughout his life, he registered more than 1,000 patents in thermodynamics, control and measuring instruments, engines, and aircraft design. Junkers had the talent of a superb organizer and was able to gather around him a team of outstanding engineers. In 1897, Junkers became interested in the idea of flight and soon concluded that the main conditions for improving flight performance were reducing aerodynamic drag and overall weight without compromising strength. For this purpose, in 1912, Junkers patented the so-called thick wing concept. In April 1914, he began theoretical work to determine the optimal wing profile, material strength, and related parameters. In total, around 4,000 tests were performed and 400 models were built. At first, he chose thin sheet iron as the structural material, but it proved too heavy for practical use. By 1916, Junkers and his team began studying the structural properties of duralumin, including new methods of forming and fastening it. Although aluminum was already used in Zeppelin airships, Junkers faced difficulties at nearly every design stage. Nevertheless, by 1917, Hugo Junkers had built 3 all-metal monoplane prototypes. On October 16, 1916, an important meeting took place at the main headquarters of the German Air Service. It was dedicated to discussing what the new armored aircraft should be like. The military insisted on a biplane, an aircraft with 2 wings, while Hugo Junkers defended a completely different concept, a monoplane with a single wing mounted above the fuselage. Junkers believed that returning to biplanes was a step backward since he had already designed several monoplanes. One of the project's engineers, Fritz Brandenburg, later explained the essence of the problem. To effectively protect the crew, the engine, and the fuel tanks, we needed an armored box weighing around 1,100 pounds. Add to that the armament, a fuel reserve for 2 hours of flight, and the communication equipment for both crew members. And it turned out that the aircraft required extremely long wings. That meant the wingspan would become so large that the plane simply wouldn't fit into any hangar or tent. After long and exhausting debates, a compromise was reached, a sesquiplane. It was an aircraft with 1 large upper wing and 1 smaller lower wing. This configuration made it possible to keep the wingspan within acceptable limits. Junkers understood all this, but he also knew one thing. Unlike ordinary airplanes made of fabric and plywood, his all-metal aircraft did not require protection from snow or rain. It didn't need a hangar or a tent, only the engine required shelter. However, the prospects of realizing the project and the heated arguments with the customer forced Junkers to abandon the idea of a monoplane. Finally, on the 3rd of November, 1916, the Aviation Department issued an official order for the construction of 3 prototypes. At the same time, similar orders were received by the Albatross and AEG companies. 4 months later, on the 27th of January 1917, the aircraft equipped with a Benz engine producing 200 horsepower made several hops at the airfield. Within Junkers' internal system, it received the designation Fourth. The aircraft was piloted by Arvid von Schmidt, who was specially assigned to Junkers for testing. Another test pilot was non-commissioned officer Wandler. At first, the plane was not fitted with armor. Instead, plywood was used. The next day, the machine was transferred to the military testing range, where Schmidt performed the first real flight. With an 8-inch layer of snow, the aircraft accelerated over 656 feet with a headwind. It reached an altitude of 820 feet and a speed of 90 miles per hour. Despite the lack of armor, the first flight did not go entirely smoothly. The tail turned out to be very heavy, and only maximum control stick deflection allowed the pilot to lift the aircraft into the air. During the first flights, Lieutenant Madelung was present. He had been sent by the military department to Dessau as an observer to oversee the aircraft's development and ensure that its design met the customer's requirements. The first flights looked quite promising, and soon an order was received for the production of 100 units. The contract for the first batch of 50 armored planes was signed on the 19th of February 1917. Several problems arose during the production of the new aircraft. First, Junkers lacked the capacity to organize mass production. Apart from airplanes, the company was also manufacturing field kitchens, water heaters, and other equipment. The second serious issue was the delay in receiving armor. Only on the 24th of May 1917 did armored plates begin arriving from the factory. At the beginning of March 1917, mandatory state tests began before the aircraft could be accepted for service. The tests took place at the Adlershof airfield. They examined strength, engine performance, and other parameters, as well as installed the full set of additional equipment. According to the rules, the aircraft had to fully match the production models, but in reality, Junkers, lacking experience in conducting military trials, presented a machine that could hardly be called ready for series production. The plane was not equipped with all its armaments and instruments. There was no radio or camera, though armor was installed shortly after the start of testing. Not all wing struts were mounted, and the upper wing itself was placed too close to the observer gunner's position, making it difficult to use the turret-mounted machine gun. Believing that Junkers would respond to criticism, the committee decided to continue testing on the condition that all necessary improvements would be made during the process. Moreover, at that time there were no established standards for testing the strength of an all-metal wing. Nevertheless, many issues were resolved. The heavy tail problem was solved quite simply. The tail section of the fuselage and the vertical stabilizer were replaced with fabric covering. A cutout was made in the upper wing, and some structural elements were reinforced. The shape of the fin and rudder was changed. For these works, Junkers used the military airfield in Halle, which had large enough hangars and a long runway suitable for this aircraft. Meanwhile, another prototype was being evaluated in Doberitz, while preparations for serial production continued in Dessau. The first production aircraft was delivered on August 1, 1917, to Flanders, assigned to the Fourth Army to join an aviation detachment. Soon after, Professor Junkers received an enthusiastic telegram from Arvid von Schmidt, who was conducting the military trials. He reported that the aircraft, flying over the town of Ypres at an altitude of 164 feet, had taken 11 hits without suffering any damage. He praised the engine protection and speed, which surpassed that of AEG and Albatross aircraft of the same specification. In addition, the plane was less affected by bad weather due to its all-metal construction. On September 23rd, a full inspection of the machine revealed that it had endured 85 hits from bullets and shrapnel, yet remained in excellent condition. By October 4, 1917, enough data had been collected to form a general impression of the new airplane. Pilots reported that the Junkers was stable in turns, remained steady even in strong gusts of wind, and was comparatively fast. Moreover, the aircraft proved extremely durable, and in case of engine failure, which happened more than once, it still offered the crew a good chance of surviving an emergency landing. However, due to its heavy weight, the Junkers required a long runway, which made operations from frontline airfields difficult. To reduce the landing roll, braking wheels were tested on one of the aircraft during flights at the Wurzen airfield, but with little success. This aircraft was part of close infantry support units assigned under the command of divisions or Army Corps. It performed excellently in low-altitude reconnaissance, even under intense enemy fire. It could drop light aerial bombs and grenades on enemy trenches. Additionally, it was used as a liaison aircraft and for delivering ammunition and supplies to friendly troops on the front lines. Despite its weak engine, poor maneuverability, and limited visibility, this aircraft quickly became popular among frontline pilots. The reason was simple: the crew was almost completely protected by an armored box. This was a true rarity for that time. The greatest danger for the crews came from enemy fighters. A single machine gun could not provide full protection from all directions, so it was recommended that these assault aircraft be escorted by friendly fighters flying above. Yet even under fire, the plane demonstrated incredible resilience. Junkers aircraft often returned from combat riddled with bullet holes, but serious crashes were extremely rare. The most famous case involved a plane that returned to its airfield with 480 bullet holes in its wings and fuselage, and still landed safely. Pilots gave the aircraft several nicknames: the Flying Tank, the Flying Furniture Van, and the Tin Donkey. The Allies learned about this aircraft only at the beginning of 1918, when several were captured during the German retreat. Some French sources claimed that one plane had been forced to land after damage from anti-aircraft fire, though no confirmation of this was ever found. The aircraft used camouflage paint that remained almost unchanged until the end of the war. The upper surfaces featured irregular patterns of green and lilac shades, while the undersides were light blue. The undercarriage struts, wheels, and armored fuselage section were painted green, sometimes with lilac patches. This color scheme was also used on other ground attack aircraft. Near the end of the war, the tail section of the fuselage was covered with fabric printed at the factory in 4 or 5 colors. To make the aircraft easily recognizable to friendly forces, additional streamers were often attached under the lower wing, and identification markings were painted on the underside of the upper wing. In the summer of 1917, the military command became even more interested in this aircraft, but due to a lack of production facilities, output remained insufficient. Although Junkers initially planned to produce from 30 to 50 machines per month, this goal was not achieved. To solve the problem, a joint venture between the Junkers and Fokker companies was proposed. Both designers reluctantly agreed to this compromise, but on the 20th of October 1917, a new company was nevertheless established. The aircraft produced by the new enterprise had a different marking on their wheels. After that, on the 6th of November, a contract was signed for the production of 100 machines at once, even though earlier they had only expected 50. Anthony Fokker soon discovered that Junkers' enterprise was poorly organized and that the staff lacked experience. And although Fokker was given substantial funding and provided with experienced personnel, the young Dutchman, as they say, washed his hands of the imposed partner, officially citing being too busy. While Fokker was occupied with his own affairs, Junkers gradually took control of his production facilities. The average monthly output in January and February of 1918 was 17 aircraft. At that time, the factory employed 522 people, but by November that number had increased to 1,070. Thanks to these measures, in October of 1918, the highest monthly output was recorded, 31 machines. Serial production was disrupted by a flood in January of 1918. Water flooded the Dillingen plant, which produced armor for the aircraft, and operations had to be halted for some time. Because of this, not a single machine was accepted in March. The company tried to find armor elsewhere, at the Ostschlesische Eisenindustrie and Rochling plants. There was another problem. In Dessau, there was no proper airfield, so finished aircraft had to be sent to Doberitz for acceptance. At the end of 1917, assembly and test flights were moved to the airfield in Wurzen, a town near Leipzig. In mid-February of 1918, the military authorities decided that the aircraft should be sent directly to the Army Air Park for delivery to the military. But because of the great distance from the factory, this was difficult to accomplish. Meanwhile, Junkers received land for a large airfield near the plant, and by the 1st of May 1918, all production, testing, and acceptance operations took place on site. However, for unknown reasons, in August, acceptance was again transferred to the Army Air Park. All of this interfered with the quick delivery of aircraft to the troops. Orders for the Junkers J.I continued to grow. On the 20th of June, 1918, a request came for the construction of 40 machines, and already on the 12th of July, the next contract for 10 aircraft. At the same time, 100 aircraft were ordered from the Linke Hofmann factory in Breslau, which were to be built under license, but production never began, and the agreement was likely terminated. The final contract was signed in October for 80 machines, but in November the armistice was signed. No new orders came in, but there was a directive requiring factories to continue producing aircraft under the supervision of the Allies. In total, by January of 1919, out of the entire order for 283 machines, 227 Junkers J.I were built, 38 of them already after the end of the war. Earlier, as thought on the 2nd of October 1918, Junkers and his staff gathered to discuss the future of the aircraft. The professor still insisted on the parasol-type layout with the wing above the fuselage. It was more aerodynamically clean, and the crew also had a better view downward and forward. The next day, during discussions, Junkers was absent, and among the engineers a rumor spread that the military authorities were considering halting production because of excessive labor intensity. It was urgently decided to focus on reducing production costs for their assault aircraft. The company already had an established assembly line operating steadily. Moreover, if aircraft production were stopped, 300 workers would be left without employment. The design bureau chose to reduce weight and remove equipment. Thus, the weight of the armor was reduced by 220 pounds. The thickness of the plates became 0.14 inches at the sides and 0.26 inches on the rear wall. They changed the wing design and increased the span, and they replaced the fabric covering of the tail section of the fuselage with duralumin. In addition, they removed the photographic camera and the radio station, equipment that was practically unnecessary for low-altitude flights. Design work was completed only in December 1918, that is, already after the armistice was signed. For modernization, they selected a production Junkers. Little information exists about this aircraft, and most likely it corresponded almost entirely to the results of the October conference. Flight tests began only in mid-January 1919, and the photographs of this machine date from the same period. Some specialists say that the modified aircraft, if put into series production, might have received the designation Junkers J.I, but this is not confirmed by any documents from the military authorities or from Junkers himself. The forward part of the aircraft fuselage formed an armor box about 11.5 feet long. Inside this armored structure were placed the engine, the fuel tank, and the crew. To make the box rigid, it was reinforced with internal joints and frames of duralumin. The armor plates had a thickness of 0.16 to 0.22 inches. The power plant consisted of a Benz engine rated at 200 horsepower. A Mercedes engine of 230 horsepower was also used. The engine was mounted on ash struts and supported by a truss of duralumin tubes and steel plates. The cylinders at the front and on the sides were protected by steel shields. The fuel tank, with a capacity of 31 gallons, made from soldered brass sheets, also served as the pilot's seat. The tail section of the fuselage was a framed structure of spars, struts, and diagonal bracing made of duralumin tubes. Both wings consisted of a center section and outer panels. The upper center section was attached to the fuselage by two crossed steel tubular struts. A conventional type undercarriage was attached to the lower center section. It was connected to the upper center section by two inclined struts. The upper wing had a span of 55 feet and an area of about 388 square feet. The span of the lower wing was approximately 36 feet. The transverse V-shaped dihedral was 5 degrees. The wing profile was fairly thick in the central part, but thinned quickly toward the tips. The upper wing structure contained 10 spars made of duralumin tubes. They were joined to each other by smaller diameter duralumin tubes, just as in the fuselage. The lower wing of similar construction included 6 spars. The duralumin skinning of the wings and fuselage was corrugated sheets with a thickness of 0.015 inches riveted to the spars. The stabilizer, with an area of about 49 square feet, consisted of 7 tubular spars, bracing, and corrugated covering. The stabilizer profile resembled the wing profile and had a maximum thickness of approximately 7.4 inches. The rudder and the fin were originally fabric covered, but later they began to be made all metal, and still later the tail assembly became entirely duralumin. Control of the rudder and ailerons was cable operated, a traditional scheme. The observer was armed with a parabellum machine gun mounted on a rotating turret. Interestingly, observers flew missions wearing infantry helmets. Like other ground attack aircraft of its class, this airplane was not equipped with synchronized guns. The machine was insufficiently fast and maneuverable for active aerial combat, and dive attacks on ground targets were impossible because of the low flight altitude and the lack of maneuverability. Drum magazines for the machine guns, in total 1,000 rounds, were readily accessible to the right and left of the gunner's position and also under the seat. In addition, light bombs with a total weight of up to 110 pounds could be suspended on special racks along the sides of the fuselage or simply carried in the cockpit. Additionally, experiments were carried out on one of the aircraft to install a battery in the floor of the fuselage. 2 Spandau machine guns that fired forward and downward at an angle of 45 degrees for engaging ground targets. In January 1918, a 20mm Becker cannon was also fitted on a mounting similar to that on the Albatross. However, both the additional machine guns and the cannon on that aircraft remained at the experimental stage. To date, only one aircraft of this type survives. It is located in Canada, at the National Aviation Museum on the historic Rockcliffe Airfield in Ottawa, province of Ontario. The aircraft was delivered there as a war trophy in 1919 and handed over to the military museum. It is now restored, but due to insufficient funding, the restoration technique used had nothing in common with the original. Before the outbreak of the Second World War, a cutaway glider in the final stage of assembly with metal skin on the rear part of the fuselage was exhibited in the Junkers exhibition hall in Dessau. Its subsequent fate after Allied air raids on March 7, 1945 is unknown. In Italy, at the National Museum of Science and Technology in Milan, a complete armored box fitted with a duralumin structural set for the rear part of the fuselage is preserved.